The beach, a place of such beauty and peace that tens of millions of people are drawn to live here. And in the warm months, tens of millions more come to vacation. This is the beach at Galveston, Texas, and it probably looked something like this on September 7th, 1900. But a day later, a powerful hurricane put the level of the water on this beach to a point 15 feet over my head, higher than the seawall built later for protection. 6,000 people were killed. It was the worst natural disaster in U.S. history. From a distance, a hurricane looks like a work of art. A radar on the ground shows geometric circles and spirals. An astronaut sees a similar sight of breathtaking beauty. And a satellite 23,000 miles up also shows nature's art. But underneath, inside the storm, art turns into terror. Hurricanes aren't the biggest storms on Earth or the most violent, but the combination of size and violence is unequaled in nature. One day's energy production in a hurricane, if it could be converted to electricity, could provide power for the entire country for 6 months.
Good evening, I'm Colleen Wine. On August 30th, the Weather Channel presented a special program called Eye of the Storm. We showed you a documentary series on hurricanes and opened our phone lines to answer your questions live on the air. We had so many calls, we were overwhelmed. So tonight, we're going to do it again. This time we've expanded our program to 90 minutes so we can talk to more of you, answer more of your questions, and maybe answer more of mine too. Here's a man who will be answering our questions, the Weather Channel's hurricane specialist, John Hope. Our regular viewers know John's work very well, but for a little bit of background, he began his career in the Air Weather Service during World War II. Later, he was with the Spaceflight Meteorology Group and was senior hurricane specialist at the National Hurricane Center. He's received dozens of honors and awards. He led the World Meteorological Organization's Pacific Typhoon Committee in a review mission to Asia, and he represented the United States at a global typhoon conference in Bangkok. We're proud to say he spent the last 5 hurricane seasons here at the Weather Channel preparing our tropical forecasts in cooperation with the National Hurricane Center. John, thanks a lot for being here.
Glad to be here.
Well, we'll be giving you our toll-free numbers in just a few minutes so you can speak with John. And of course, throughout the hour, you'll be seeing your local forecasts. In fact, we have one of those local forecasts next. And then on Eye of the Storm, Glenn Schwartz will show you what it's like inside nature's most devastating storms as he takes a ride through a hurricane. In early summer, the sun hovers over tropical waters, warming them well into the 80s. Sounds enticing, but that's just what hurricanes need to form. Exactly how they form is the subject for our next segment. Here's Glenn Schwartz.
Hurricanes form only over the warm tropical oceans, near but not at the equator. Several form in the Atlantic each year and either curve away from the coastline, hit the U.S., or continue into Central America. Now, even more form in the eastern Pacific. A few of these strike the Mexican coast, but most move away from shore, like this one. A rare hurricane can reach as far as Hawaii, though. Look at what Hurricane Eva did to the island in 1982. Huge stretches of warm Pacific water allow lots of storms to form. The name is different. They're called typhoons here when winds reach 74 miles an hour, and there are more of them in the western Pacific than any other place on Earth. They often hit Southeast Asia and tend to be the biggest and strongest anywhere. This one is getting dangerously close to Japan. They're called cyclones south of the equator over here, and Australia occasionally gets hit by one. As you can see, they spin the opposite way from storms in the northern hemisphere, but are otherwise the same. Cyclones also form over here in the southern Indian Ocean. Back north, we find a few cyclones in the Arabian Sea. But the deadliest storms on Earth, also called cyclones, form in the Bay of Bengal. where even weak cyclones can lead to disaster. In 1970, a cyclone struck Bangladesh, killing an estimated 500,000 people. But hurricanes don't just cause death and destruction, they exist for a reason.
We begin to see this tremendous buildup of heat in the tropics. You got to get rid of it. Well, nature's got a very effective way of doing that, and it's called the hurricane. Hurricanes are bad enough, but if we didn't have hurricanes, we might have something even worse.
Our hurricanes often are triggered by disturbances that form over Africa. About 100 disturbances move across the Atlantic each year between June and November. Yet an average of only 6 develop all the way into hurricanes. There are 2 other sources for hurricane development. One is from a persistent band of clouds north of the equator called the Intertropical Convergence Zone. Sometimes a patch of clouds breaks off, moves north, and forms into a hurricane. The other cause is an old front that has moved through the U.S. and stalled in the warm waters. After a few days, a large mass of clouds can strengthen into a hurricane. How does a mass of clouds form into a hurricane? Well, the exact process is very complex and not fully understood, but we can demonstrate some of the principles in a kitchen. We know that hurricanes need a heat source, an ocean temperature of around 80 degrees Fahrenheit or higher. That heat ends up in the air in 2 ways. As we warm this pan of water, we can feel the heat rising into the air well above the water. That's the first means of heat transfer. The other way can be seen by watching the water for a long time. It gradually disappears. But it hasn't really disappeared, it's evaporated into the air. The energy that went into evaporating the water also goes into the air and is released later as heat when the cloud droplets form, or in this case, the water droplets in the mirror. In a developing hurricane, the pressure at the center falls as the warm air around it rises. Surrounding air then begins to move toward the lower pressure. The Earth's rotation causes the air to spiral around the low, counterclockwise in the northern hemisphere. Another obvious question is, why do so few low-pressure areas in the tropics become hurricanes?
It takes a special, unique combination of a number of different events, apparently for the tropical storm or the hurricane to form.
That precise recipe of winds, clouds, and temperatures is only reached occasionally. Once it develops, the most unique and easy-to-identify feature of a hurricane is the eye. It's an area of no rain, light winds, and few clouds produced by sinking air. It usually ranges from 15 to 30 miles across. The lowest surface air pressures are found here. Surrounding the eye is the eye wall, a towering cylinder of clouds 8 to 10 miles high. The air is rising rapidly, and the heaviest rain and strongest winds are found here. A plane flying through the eye and eye wall shows the incredible contrast between the two. Much of a hurricane's energy is concentrated in the eye wall. Away from the center of the hurricane, we can see the spiraling of clouds around it. Under the clouds, spiral bands of heavy rain and strong wind gusts can cause brief bursts of stormy weather hundreds of miles from the eye. The entire area affected directly by a hurricane is often several hundred miles across, with the area of maximum destruction about 50 miles wide. In contrast, a tornado, represented by the dot, would affect only a small fraction of the area. A 3-dimensional view shows another part of the structure of a strong hurricane, the upper-level wind outflow. If air blows in near the center, then rises, it has to go somewhere. So at high levels, air needs to be blown away from the eye wall. Let's take a trip through the hurricane now as I shrink down to the size of a particle. Gentle winds are carrying me closer to the storm. I'm now crossing a spiral band. The wind picked up and it's raining hard. Now it stopped and the winds are lighter. Here it goes again, another spiral band. Now as I get closer, the wind and rain are becoming stronger. I've now been carried into the eye wall, experiencing the full fury of the hurricane. The winds and seas are incredible, and I'm being carried upward, fast. Now I'm reaching the top of the storm, and the upper level flow is turning me the other way, clockwise. I'm being blown away from the storm, and the winds and rain have let up. And now I've been thrown hundreds of miles from the eye. What a ride.
So that's basically how a hurricane forms. Now, once it forms and hits land, it can become a killer. But this year's season has been relatively quiet. Wonder why? or more importantly, if it will continue that way. Call us at 1-800-327-0945 or in Georgia, 404-434-9762. Welcome back to the Eye of the Storm. We're going to take our discussion on now, and well, basically, John, the reason we're doing this again is to get more people's phone calls, so let's head right to the phones. First phone call is from St. Petersburg, Florida. Go ahead, you're on the air.
How dangerous would a hurricane be to Tampa Bay area?
I barely even heard that phone call. I believe she said, how dangerous is it in the Bay Area?
Well, it could be very dangerous indeed.
Tampa
Now,
Bay,
they've
yeah.
been very fortunate in the Tampa Bay area that they have not had a major hurricane there since 1921. That was the last major hurricane they had. Hurricane Donna in 1960 was a close call, but it could be very dangerous because if a hurricane approaches from the southwest, first of all, a lot of water would blow out of the bay with the northeast winds, and then once the hurricane got up there, it would come back in with a rush, and it would inundate a whole lot of low-lying areas around the bay, as well as the offshore islands. There are an awful lot of people living in offshore islands around Tampa Bay, and some of those would be inundated.
Okay.
So it could be very dangerous.
Okay, let's head to the other side of Florida now, to Hollywood, Florida. You're on the air. What's your question, please?
I'm Jan Lederman. Hello, Colleen. Hello, John. Dr. Neil Frank noted that we've made great progress in observation of the movement of hurricanes, but not in forecasting their movement. He also noted the population problem we face with tens of thousands of people who now live along the coast. My question is, why is so little progress being made with specific regard to forecasting hurricane movement and weather in general, and how will this inability to forecast affect orders for evacuation should a storm approach a densely populated coastal area?
Well, the reason we're not doing better is not because a lot of very capable people are not working on it, because they are. And it is indeed getting a little bit better. We hear a lot about the average 24-hour error being 100 miles, but that includes a lot of storms that are way out on the ocean where we don't know exactly where they are at night, especially we just have satellite pictures to go on. Now, if we look at the average landfall error for 24 hours, for example, then it shrinks down to about 50 miles. If we're talking about 12 hours, it's about 25 miles, so it isn't really all that much. But indeed, I would agree with Dr. Frank that we do have a problem because of the influx of people into the hurricane-prone areas, and there are a good many areas that might have to be evacuated in the face of a major hurricane where the normal warning time wouldn't be enough. The Hurricane Center can only hope or promise to give maybe 24 hours warning, and sometimes it's not going to be as long as that. And there are areas where it would indeed take more than 24 hours to evacuate, so we are very concerned about this.
Yeah, that viewer did bring up a very important point. Oh, let's head on to New Orleans right now. You're on the air. What's your questions, please? New Orleans?
Greg Gobert from New Orleans. How you doing, Colleen?
Real good. How are you?
I'm doing pretty good. I have a question for Mr. Ho.
Yeah.
I have a history question. What's the lowest barometric pressure of a hurricane that's ever been recorded?
In the Atlantic Ocean, the lowest we've ever had was 899 millibars. That was in Hurricane Allen in the Gulf of Mexico back in 1980. But fortunately, that hurricane weakened quite a bit before it came ashore. Now, the next lowest was Hurricane, the Keys hurricane of 1935. That was 892 millibars, and Hurricane Camille then would be third. That was 909 millibars.
So how does that convert into inches, which is normally what?
Well, Hurricane Camille, I think that was about 2642 inches, so it's about 3 inches lower than normal atmospheric pressure.
Woo!
There have been some incidentally lower than that in the Pacific typhoons. I think Typhoon Tip in the Pacific had 876 millibars or something like that. Much, much lower.
Okay. Well, let's head up the East Coast now. Our next phone call is out of Bristol, Connecticut. Go ahead, please. You're on the air.
Hi, Colleen. How you doing?
Real good. What's your question, please?
Well, I was wondering, you have a Willis symbol for a tropical storm, you have a Willis symbol for a hurricane, but do you have one for a tropical depression?
As far as the maps, I believe you
Yeah,
said.
the answer is we do not. We just put on our maps just a low pressure symbol if it's a depression and not yet a tropical storm or a hurricane.
Can that be a little bit confusing though, because we have a low pressure system? We do use a different type of L though.
Well, here at the Weather Channel we use a small L if it's a tropical system like a tropical depression, but Low pressure systems are generally marked with an L anyway, and so there isn't that much difference in the markings, but we do not have a special symbol. Maybe we should have.
Maybe we should. Maybe that's something we'll have to think about.
Right.
Okay, well, we still have a lot of calls on the line, so if you get a busy signal, just keep trying. And we've got a lot more to say about hurricanes, what they are, what they can do. And we're waiting for your questions. Our number, 1-800-327-0945. And in Georgia, area code 404-434-9762. We'll be answering. Continuing our discussion of hurricanes here at the Weather Channel during Eye of the Storm. We're going to go right back to the phones for our next phone call. This one's out of Milwaukee, Wisconsin. Go ahead, please. You're on the air.
Good evening.
Good evening.
I'm a meteorology major out of UWM.
Yes.
And our meteorology class is studying hurricanes right now. And our teacher made a statement saying that a hurricane can come on land and go to the Great Lakes. Is that possible?
Is it possible for a hurricane to form in the Great Lakes?
Well, I don't think so. We have no record of one ever having formed over the Great Lakes, so I'd have to say no. We have about 100 years of record or more, and no record of a hurricane forming over the Great Lakes.
Is there something that could be similar? And I know the hurricanes take very warm water, obviously, to develop.
They do, but they take a rather larger body of water than that, than the Great Lakes. And actually, the only way it can possibly develop over the Great Lakes, I guess, would be for the lakes to get very warm. They don't normally get that warm. You know, the temperature in the lake out in the middle of the lake has to be 80 degrees or higher. It would be for a hurricane to form. So I think we could dismiss the possibility of a hurricane forming over the Great Lakes. Sorry about that.
I think a teacher's going to be a little bit upset. Let's go to Zanesville, Ohio right now. You're on the air.
Hello, I'd like to know what the most destructive hurricane hit North Carolina.
I guess I'd have to say that Hurricane Hazel in 1954 was the most destructive. That was a very, very destructive hurricane. It wiped out a whole lot of beach communities, and it was an extremely strong hurricane, moving very fast, and did a great deal of damage in North Carolina.
Okay, well, that's pretty serious when we get into that area, and it has been rather quiet over the past couple of years. Well, let's go to Wilmington Island, Georgia now for our next phone call. Your question, please?
Yes, my name is Cecilia Moret.
Yeah.
I'm calling from Wilmington Island, Georgia, and I would like to ask John, how would I tell, living on this island, if this island has ever been underwater from a hurricane before?
Do you happen to know if that island's ever been under?
I didn't quite catch the name of the island.
Wilmington Island, Georgia.
Well, the islands off the coast of Georgia and South Carolina have indeed been underwater. It's been a long time ago, but in the hurricane of 1893, islands such as Hilton Head and even at Savannah Beach, the water was about 20 feet high. Hilton Head was entirely underwater, and that was a very tragic event because a lot of people did drown there. So I would say that any island off the coast of Georgia could go completely underwater in a major hurricane.
We see problems around Cape Hatteras as well. I think it's US 12 that consistently gets washed
It
out.
doesn't take so much to put 12 underwater there. They go underwater pretty often there.
Yeah.
Along the Outer Banks.
Yeah, well, that is a serious problem, and we're keeping an eye up and down the coast of Florida. That's something we'll be discussing a little bit later as well, as along those barrier islands, the problems that we're seeing in those regions.
Well, all the islands, the barrier islands concern us because both off the west coast of Florida, the east coast, and on up into the Carolinas, and even on up into New England, we have the barrier islands. And none of these are very high, and they can all go underwater in a major hurricane. Each one at a time, not all of them at once, but
right.
Depending on where the hurricane hits.
Okay, let's head into Indiana, Valparaiso, Indiana. You have a question, please?
Are conditions favorable for the further development of the new tropical depression in the Atlantic?
Well, as a matter of fact, that new tropical depression is already a tropical storm. It just was named a tropical storm this afternoon as Tropical Storm Emily, and it's been developing very rapidly this afternoon. It's only about 180 miles or so now from Barbados, moving about 20 miles an hour. We think this is going to go through the islands very likely before tomorrow morning or before tomorrow noon, and it looks as if even as we speak that it is developing further. That is the 5th storm of the season. That's Emily.
Okay. Well, we're going to take a break from our discussion right now, but John and I will remain here in our meteorology lab, where, by the way, our forecasters are hard at work. We'll still be accepting your phone calls at the numbers on your screen, but in the meantime, we have another segment of our documentary on hurricanes. This one explains how an effect of a hurricane causes destruction, the storm surge. Most deaths in a hurricane are caused by drowning. Drowning in a mound of water known as a storm surge. Once again, here's Glenn Schwartz.
Satellite pictures prove that no two hurricanes are alike. Some are much bigger than others. Some produce more rain. Some have bigger eyes. Some have their spiral bands concentrated on one side. There are differences in intensity, too. Hurricanes are measured on the Saffir-Simpson scale, which ranges from 1 to 5. A 1 is a minimal hurricane with highest winds barely 74 miles an hour. A 5 has winds over 155 miles an hour. But even the wind of a Category 5 hurricane is not the most dangerous aspect of the storm. The biggest threat is water. It's hard to imagine that something as peaceful as ocean water can turn into such a killer. But water is extremely heavy. A cubic yard of it weighs nearly a ton. Imagine winds pushing that ton of water along at incredible speeds. Multiply that by the millions of cubic yards of water out there, and you have phenomenal power. Power in a killer called the storm surge.
9 out of 10 people who die in a hurricane drowned in the storm surge. Now, this is a dome of salt water, maybe 50 miles wide, that sweeps across the coastline near the point where the center of the eye makes landfall. Now, on top of that dome, you have wind waves, 5 and 10-foot waves that come lashing at the shore.
The storm surge is a mound of water partly created by the low pressure in the eye of a hurricane. I've lowered the pressure inside this straw by drawing air out of it, and the level of the liquid rose. The same thing is true on a much larger scale out in the ocean, and the level of the ocean water can rise a couple of feet above normal this way. Since an actual storm surge has never been filmed, we'll have to simulate it. On a given day, the tidal level comes up to the blue line with small waves on top. As a hurricane approaches, the water level gradually rises, perhaps a few feet. The water level rises rapidly when the storm surge hits, usually near landfall, that is, the time when the eye reaches the coast. It might rise 4 feet in 4 minutes or even faster. Let's say the total storm surge adds up to 10 feet with huge waves on top. The final water level varies according to 3 main factors. First, the tides. The moon's alignment with the earth and sun actually plays a role. Some places have huge differences in height between low and high tide. Our sample storm at low tide might raise the water level only 4 feet, while at high tide, the total would be 16 feet. Second, the shape of the ocean bottom. Deep water near the coast means a smaller surge, perhaps 4 feet instead of 10. Shallow water would cause a much higher surge, perhaps up to 16 feet. This is why the same storm causing a 15-foot surge on the Florida East Coast would cause a 25-foot surge on the west coast of the state. The third factor is the shape of the coastline. As this demonstration shows, a straight coastline produces a certain surge. But the same wave hitting a concave coast produces a much bigger surge. It is the combination of high tides, shallow water, and a concave coast that led to the catastrophes in Bangladesh. Look at what storm surges have done in this country. The surge of the 1900 Galveston hurricane put the island completely underwater. Structures that looked safe ended up as flat as the shacks. More recently, Camille's surge in 1969 reduced the Richelieu apartments back to its original concrete slab. After the storm surge, wind is the second most dangerous aspect of a hurricane. Buildings that might survive 100-mile-an-hour winds can be blown away at 200 miles an hour. Even heavy objects can become deadly missiles. Each doubling of the wind speed increases the force of destruction 4 times. So the destructive force of a 200-mile-an-hour wind is 100 times greater than the force of a 20-mile-an-hour wind. Another hurricane danger can be tornadoes. The twisters tend to form just ahead of hurricane landfall, but are weaker and don't last as long as Midwestern tornadoes. Once a hurricane makes landfall, the energy source is cut off. The warm water isn't there anymore, and as you can see by the eye filling in with rain, the storm loses its structure. But the total rainfall often increases. It's hard to measure hurricane rain because it blows sideways and often misses the rain gauges. Rains up to 30 inches have been measured, resulting in disastrous flooding. Agnes was a minimal hurricane when it hit Florida in 1972. It then weakened even more, but stalled over Pennsylvania and New York, dumping up to 20 inches of rain. The resulting floods caused 122 deaths and billions in damage. Let's now look at a sample hurricane from 3 different locations in its path. Imagine Hurricane Zelda approaching a straight coastline, moving 10 miles an hour. A 200-mile wide area has been evacuated because of the threat. We'll look at points A, B, and C along the coast, 50 miles apart, and watch their winds and water levels. 24 hours before Zelda hits, all have 10-mile-an-hour winds and normal tides. 6 hours before landfall, A has 20-mile-an-hour winds from the north and a 3-foot rise in water level. B has 25-mile-an-hour winds and a 5-foot increase in water level. C also has 25-mile-an-hour winds from the southeast and 5 feet of water. The conditions continue to worsen until the eye wall hits the coast. A's winds are now 50 miles an hour, but since they're blowing offshore, the water level is now below normal. At B, the wind has increased rapidly to 160 miles an hour with a 16-foot rise of water. And C has 70-mile-an-hour winds and an 8-foot increase in water level. A half hour later, A has 50-mile-an-hour winds and the water is still below normal. B is in the eye, 10-mile-an-hour winds, but a high chaotic water level of 16 feet. C still has 70-mile-an-hour winds and an 8-foot water level. But the worst part of the storm is between B and C. A wind of 190 miles an hour from the south is added to Zelda's 10-mile-an-hour forward motion, so the total effect is a 200-mile-an-hour wind with a peak storm surge of 20 feet. A half hour later, A's conditions haven't changed much. But at B, the wind has increased rapidly from the opposite direction, and the water level is still high. At C, winds and water levels are decreasing. The worst of Zelda is over.
Still to come on Eye of the Storm, would you and your family know how to survive a hurricane? We'll be taking your phone calls again at 1-800-327-0945, and in Georgia, area code 404-434-9762, right after your local forecast. Stay with us. Continuing our discussion on Eye of the Storm, we're heading right back to the phones. First phone call this segment is out of Wilmington, North Carolina. Go ahead, please, you're on the air.
Hi, Colleen.
Hello.
Has there ever been a hurricane season where a hurricane has not hit the East Coast?
Has not hit, okay, John?
There have been a great many seasons when we didn't have one hit the East Coast. As a matter of fact, there have been about 15 years in this century where we didn't have any landfalling hurricane, either along the Gulf Coast or along the East Coast. Now, it turns out that we have an average of about 17 storms hit hurricanes, actual hurricanes, hit the United States coast each decade, and that, you see, is a little less than an average of 2 per year. Now, we've had very few times where we have had as many as 2 consecutive years without any. That's only happened twice. I believe it was 1930 and 1931, and again in 1980 and 1981. I might be a year off, so it turns out about every 6 years, on an average about every 6 years, we go without having a hurricane make landfall anywhere on the U.S. coast.
And it's looking pretty quiet this year, too. Earlier, a couple of years ago, we had a big problem as far as Gloria, and as we head up into New York, and as far as a hurricane getting that far north. And there was a big difference between if it would have struck during high tide and low tide.
Well, we were very concerned about a hurricane like Gloria because, in the first place, we had not had a major hurricane go up the East Coast in a very long time, and folks up in that area weren't exactly accustomed to having that kind of a hurricane. In fact, this hurricane, as it came up the coast, was stronger than any other hurricane since the 1938 hurricane that devastated Long Island and New England. And one of the big differences between these two hurricanes, I don't mean to say that Gloria was quite as strong as the 1938 hurricane was, because it had weakened some. But the main difference was that Gloria came in up in Long Island and New England on low tide, whereas the 1938 hurricane came in on high tide. Now, had that hurricane come in, we have a map here showing you the boroughs of New York City, and I'd like to show you the areas that would have been flooded with Gloria no stronger than it was had the hurricane come in on high tide. So there would have been considerable flooding in the boroughs of New York if that hurricane had just come ashore on high tide. So it's very important up in that part of the country, whether we are talking about one that comes on high tide or low tide, because there can be as much as 6 or 8 difference between the astronomical tide at high tide and low tide. So almost the whole thing on the southern coast of Long Island and New York is whether it comes in on low or high tide. I know a lot of people in New York City felt that that hurricane was perhaps over forecast just a bit, but you know, people that lived out on Long Island that didn't have any electrical power, for example, for a month, I'm sure they knew there had been a hurricane.
And that's true, and also we have a problem with false impressions. When people experience something like that with a hurricane coming in, the next time we see a hurricane in that area, we might have a problem getting some people out in case it does come in during high tide.
Well, Colleen, that's one of the biggest problems, of course, in the hurricane forecasting business, is what people's perceptions might be. And you're exactly right. They do tend to base their actions when a hurricane threatens on whatever it was that they experienced in the last hurricane. And this does cause a lot of trouble. We've done a lot of interviews, and a lot of groups have done interviews, asked people, well, why didn't you evacuate? And they would say, well, one person that was in Hurricane Camille and didn't evacuate and survived. Well, they said that they were in Hurricane Dora up in Jacksonville in 1964, and they thought that's what a hurricane was. You see, because the main area of the hurricane is only about 50 miles wide, most people are much more likely to experience the periphery of a hurricane than they are the core of the hurricane. And unless one experiences that core of the hurricane, this swath about 50 miles wide, they really don't know what a major hurricane is.
Okay, well, let's get back to the phones and go to Fort Worth, Texas right now. Fort Worth, you're on the air. What's your question, please?
Yes, I just need to ask Mr. Hope a question. If we have a season where we have very little or no tropical storm activity, will it affect the coming seasons, like winter and fall and the next spring?
That's an interesting question.
That is interesting, and we've had a lot of studies on that, but I'm afraid that we haven't been able to make any very good correlation on that. One would think offhand that there would be some cause and effect there that we could measure, but as we make studies of seasons that had a lot of hurricanes compared to those that didn't have very many, and then when we look at what the subsequent winter is like, we've just not been able to find much of a correlation.
Okay, real good. Let's head back to the phones now, and this one's out of Atlanta, Georgia. You're on the air, please. What's your question?
Good evening, Colleen. As an airline pilot, I'm interested in the type of reconnaissance aircraft that are used to fly into the eye of these hurricanes, and is there a desirable altitude to penetrate these rings?
Recon flights.
Most of the reconnaissance aircraft that are flying into hurricanes these days are flown by the Air Force, and they fly the C-130 aircraft, which is a turboprop plane. It's not a pure jet, because the jet really goes too fast, and that kind of magnifies the turbulence, so the turboprop is better. And as to what the optimum altitude is, generally speaking, if there is an investigative flight out there before a storm becomes a hurricane, then they fly in a low altitude, which is around, say, 1,500 feet or so. But once it gets to be a full-fledged hurricane, they're likely to fly in at much higher altitude, about 10,000 feet or so.
How do they choose those people? Is that a volunteer basis, or?
Well, I'm sure it's mostly volunteer, yes. And it's not that bad. A lot of people just love to go out there, and we have a lot of people standing by who want to go along as passengers. There's no shortage of people who like to fly on hurricanes.
Well, that definitely would be interesting. Let's go to our next phone call. This one's out of Long Island, New York. You're on the air. What's your question, please?
If the hurricane of 1938 hit Long Island today, what would the damage be like?
I would hate to think what the damage would be like. It would be tremendous damage. I think even in the terms of 1938 dollars, for example, there was about $250 million or something like that. We calculate today in terms of the dollars in 1980 that if that same hurricane hit that same area, the damage would just literally be in billions, more than 2 billion anyway. And places out on the island there, out around the Hamptons and Montauk, a lot of those beach places were completely wiped out. And today, there are a lot more places there than there were then. So I would really hate to think what the damage might be on that same hurricane coming in at high tide.
Might not be a good situation. We're going to pause right now for station identification and then take a look at your local forecast. Well, if you've been trying to get through and our lines have been busy, call now, because we'll be coming right back for more of your questions about hurricanes. Our numbers, 1-800-327-0945, and in Georgia, area code 404-434-9762. As we continue through our next hour of our Eye of the Storm, our special documentary, we're going to take a phone call right now out of Pittsfield, Massachusetts. You're on the air. What's your question, please?
I'd like to know how many hurricanes have come into the coast of Massachusetts, and I'd also like to know if there is a pattern from season to season on the hurricanes.
A pattern as far as hitting the East Coast, or any sort of pattern?
Which would let you know if you have any idea about how many would possibly hit the East Coast. Yes.
East Coast.
Well, we can't tell, of course, ahead of time how many there might be, but I think we ought to point out, though, that in New England, the hurricanes are relatively rare, and major hurricanes are even rarer still. Now, we know there have been some tremendous hurricanes in New England, but I'd like to give you a little bit of an idea of how far apart some of these were. The first one was only 15 years after the colony was settled. That was in 1635, and that was a tremendous hurricane. And we have a very good account of that hurricane from John Winthrop, who was governor of the colony. And you know, then there was one in 1638, not quite as bad, but it was really an awful long time before we got another hurricane of that magnitude into New England. It was 1815. And after that, then, there was the famous hurricane of 1938, which was a very damaging hurricane. And then we had some other hurricanes, almost as bad as that. In the 1944, there was a major hurricane came to New England. And then there were hurricanes Edna and Carol in 1954. And finally Hurricane Donna in 1960. So you see they're pretty far apart. Now we had this one episode, this century, only one episode, in the 50s, where the hurricanes all seemed to want to go up the East Coast, the major hurricanes. Well, we've been out of that now, and we've been out of it for quite a while until we got Gloria. That was the first one in a long time major hurricane that came up there. In 1976, there was Hurricane Bell, but that was a much weaker hurricane. And as I talked about the last time, talking about New England hurricanes, I think it's important to say that no hurricane is going to be a major hurricane or a damaging hurricane like the 1938 hurricane in New England, unless it, number one, comes in on high tide and also moves very fast. If it doesn't move rapidly from, say, Cape Hatteras up to New England, it's going to weaken, because a hurricane has got to have warm water to maintain it. It's not the distance that it travels over cold water, but it's how long it takes it to do it. How long it takes it to do it.
So basically, to answer our viewer's question, there really isn't a pattern.
No,
they're kind of sporadic.
And compared to the rest of the country, they are rare, but I think that because they can be so devastating up there, that people have got to assume every year that there's a possibility that one will come up there.
Okay, let's head to Savannah, Georgia for our next phone call. You're on the air.
John, hurricanes seem to come up the Gulf Stream currents along the East Coast. What would cause it to break from these currents and come into a place like Savannah, like David did?
Well, they do kind of follow the East Coast, but because of the warm water current that goes along the East Coast, but remember that the warm water current is also created by the winds, and the hurricanes are steered by the big, large-scale flow in the atmosphere, as Neil Frank calls them, rivers of air. That's how they're steered, but that can vary some, and that does not always have to be at a given time the same direction as the Gulf Stream is. It can vary, and the flow can come from ocean to land, and that could make the hurricane move inland.
So hurricanes follow rivers of air, not bodies of water.
No, that is exactly right. Even though, of course, the Gulf Stream, the reason it goes as it does has something to do with the wind flow also.
Okay, heading up the East Coast now to Baltimore, Maryland. Your question, please.
Yes, hi, Colleen. How are you this evening?
Good evening. Your question?
Yes, I need to know, how close was the eye of Hurricane Gloria to the Maryland coast?
It wasn't all that close. I seem to recall that it was about something like, now don't hold me to this exactly, something like 30 or 40 miles off the coast. But the important thing to realize about the eastern shore of Maryland relative to Hurricane Gloria was that the Maryland coast was on the west side of the hurricane, which was the weak side of the hurricane. Now, when one begins to move pretty fast, you can sort of add the speed of movement to the winds on the east side of the hurricane, and you kind of subtract that speed of movement from the west. So the Maryland coast was very definitely on the weak side of the hurricane. Even so, I know that along the coast of Maryland, there were some very high tides, for example, at Ocean City.
So it will affect it some, but
it did affect it some, but it wasn't nearly as major as it would have been had the hurricane been a bit farther toward the west.
Okay. Right now behind us in our meteorology lab, our meteorologists are continuing to work on your forecast, and we'll still be accepting your phone calls at 1-800-327-9045, and in Georgia, area code 404-434-9762. And when we return on Eye of the Storm, after your local forecast, we'll take a look at the problem of trying to evacuate the hundreds of thousands of people in coastal areas when they're threatened by a hurricane. Lives in a hurricane is largely a problem of convincing people that they may be in danger. In this segment, we look at that problem.
Only people who've lived through the eye-wall weather of a major hurricane know its true power. For others, it's easy to develop feelings of overconfidence.
Most of us on the coastline go through the fringes of a major hurricane, or we go through a minor storm, and then we form false impressions about what a bad hurricane is all about. Another thing that behavior scientists tell us is that we think we know more about things in life than we really do, if we haven't experienced the worst. And I think that's true in hurricanes.
Two statistics about the coastal population illustrate the problem. Development along the beachfront, such as this, is increasing at a rate 3 times faster than in the rest of the U.S. And 80% of the people who live along the Atlantic and Gulf coasts have never experienced a major hurricane. In addition, there are the millions of people who visit the beaches during hurricane season. Evacuation of vulnerable areas takes 20 hours or more in many places. Here in Galveston, it's 25 to 30 hours. No one can provide that much lead time in a warning.
We're more vulnerable to the hurricane than we've ever been in our history, and it's primarily a people problem, all right? It's because we're locating thousands and tens of thousands of people on islands that historically have gone underwater.
Hurricane strikes are a fact of life along the Atlantic and Gulf coasts. Even Columbus ran across a hurricane in 1494. History since then is littered with disasters, from the Caribbean to New England and westward to Texas. All Atlantic and Gulf coastal areas are vulnerable to hurricanes, but Dr. Frank is especially concerned about several particular places, including Galveston, the Tampa Bay area, the southwest coast of Florida, the Florida Keys, and the islands off New Jersey.
New Orleans, though, has got to be the #1 vulnerable area in the United States. You got the Gulf to the south, you've got a major lake to the north, and a huge river through downtown. And a lot of the city is below sea level. And they've got all kinds of levees over there that give people a false sense of security.
There are many problems in trying to evacuate a highly populated coastal area. There are few evacuation routes, some with only 2 traffic lanes. Many of these routes are only a few feet above sea level. That means they would be flooded by increasing waters hours before landfall. Boats would be trying to move inland too. Imagine thousands of cars and hundreds of boats trying to pass a drawbridge. And with high winds, heavy rain, and a hasty evacuation, accidents are inevitable, slowing the process even more.
Some chilling realities to think about for those of you that live in these communities. We'll continue with our discussion about hurricanes and the dangers they present to you and your family after an update on the road conditions and your local forecast. Our phones have been very busy, but please keep trying the numbers you see on your screen because we'll be answering more of your questions right after this break. Now here's Dave Watson with your Michelin Drivers Report. Discussion now on Eye of the Storm. I'm Colleen Wine alongside our hurricane expert John Hope. Heading back to the phones for our first phone call this segment out of St. Cloud, Minnesota. You're on the air. What's your question, please?
Thank you, Colleen. I enjoy the Weather Channel a lot, and I'm in broadcasting, and we've had the warmest year on record here in St. Cloud. And I was wondering, they talk about the El Nino effect having to do with our warm year, Has that anything to do with the fact that there is a low incidence of hurricanes, John, this year?
Well, we believe that the El Nino certainly does have an effect on hurricanes, and it causes fewer hurricanes in the Caribbean Sea and the Gulf of Mexico, and maybe even the Western Atlantic. Professor William Gray out at Colorado State University has been doing a lot of studying on this, and we've been able to go back now for about the last 40 years or so, and we find that whenever we do have an El Nino, we do have fewer hurricanes. Now, the El Nino doesn't occur every year. It occurs periodically on the average of about once every 5 or 6 years, something like that. And we had an El Nino begin last year. It's still there, and they're getting warmer than average temperatures in the East Pacific off the west coast of South America, and that does seem to cause fewer hurricanes for sure, especially in the Caribbean Sea. One reason we believe that that might be the case is that when we have a lot of thunderstorms and even hurricanes out there in the East Pacific, we have stronger westerly winds across the Caribbean at high altitudes than we normally do, and we think that does inhibit some. It's a very marked signal. We think that we can rely on that a little bit. In other words, if we know we're going to have an El Nino, we can be quite sure that there will be fewer hurricanes in the Atlantic area than, say, normal.
Okay. All right, I've got something to relate to that, but I want to head back to the phone right now to Hemet, California. You have a question. Go ahead, you're on the air.
Okay. I live in Southern California, right, and we get a lot of moisture coming in from Mexico. I was wondering in the history books if a hurricane has ever hit Southern California area, coastline.
It is very rare indeed for one of those specific hurricanes to come up and hit California, but it has happened. Now, the last major hurricane that came from the Pacific and came up to Southern California was in 1939, and it did a great deal of damage, especially around the Los Angeles and the Santa Barbara area, but it's very rare indeed, but again, it can happen.
But the odds are very low?
The odds are very low that it will happen, but it's not impossible.
And that I'm sure gets back to the temperature, the water temperatures, again, around the California coastal areas being relatively low.
They are quite cold, and down there where the hurricanes form, of course, in the East Pacific is very warm. The temperatures are well over 80. But the same as when a hurricane goes up the East Coast, the water temperature gets colder very rapidly. In order for this hurricane to maintain itself, it would have to come up there pretty fast, and most of them don't come that fast.
Okay, heading into Texas. Lubbock, Texas, you're on the air. What's your question, please?
Yes, as the storm hits the coast, does it retain its strength or does it weaken?
When it makes landfall, does it increase or decrease?
No, when the hurricane makes landfall, it weakens. Remember that the energy to fuel a hurricane is the warm ocean water. And as soon as that is cut off, the supply of warm water, whether it goes over colder water or whether it goes over land, it's going to weaken. And it'll weaken fairly fast. It depends a little bit on what kind of terrain it is inland. If it's a flat country, it may not decrease quite so fast. If there are mountains there, it will tear it up somewhat quicker. I think a pretty good rule of thumb is if it's over flat country, that it should lose about 50% or so of its strength as far as the winds go within 12 hours.
And then we just have to worry about the rainfalls. Let's head to Buffalo, New York right now. You're on the air. Your question, please.
Yeah. How far north in the continental United States has a hurricane reached?
How far north? I'm assuming that she means hurricane strength.
Yeah, all the way up the East Coast as far as Eastport, Maine, which is about the farthest city up along the coast of Maine. Hurricane Hazel in 1954 came inland, and that came inland near Myrtle Beach, South Carolina, went up through North Carolina and Virginia and Maryland, Pennsylvania, and even still had hurricane force winds when it got into Ontario province in Canada.
Whoa, so moving very quickly then up the coast.
Yes, it was.
Okay. Well, right now we're going to take a bit of a break. Ordinarily, being stuck in traffic is a bit annoying. But when it comes down to a situation like the one you're seeing here, it can be a matter of life and death. This is the kind of situation we'd like to help you avoid. So if you have any more questions, give us a call. We know our lines are busy, but please keep trying. We want to hear from you. Thanks for joining us here on the Weather Channel during Eye of the Storm. We're heading back to the phones right now to Vero Beach, Florida. You're on the air. Your question, please.
Yes, my name is Eric. I was wondering how come more hurricanes seem to go into the Gulf rather than up the Atlantic coast of Florida or the United States.
Okay, more of them seem to be in the Gulf than up the East Coast.
Well, again, we're in a period, as we look back say all the way back to 1900, as a matter of fact. What we notice is that we've seen a lot of cycles there. We can take that whole period from 1900 to 1920. Most of the hurricanes then hit in the Gulf of Mexico also. And then along the late 20s and 1930s, we had them begin to hit along the southeast coast of Florida. We had the 1926 hurricane that hit Miami, the 1928 hurricane that hit Palm Beach, and one in the Keys in 1933. And then in the 40s, almost every hurricane, major hurricane that hit the United States hit somewhere in Florida. And then it was only in the 50s that we had this period where they go up the East Coast. And it just seems as if those episodes where they go up the East Coast don't last as long. Because we've had now, after 1960, we had a lot of hurricanes go up the East Coast in the 50s. Donna in 1960 was the last one. And then everything shifted back to the Gulf in 1960. And it maintained that for about 20 years and more until 1960, until into the 1980s. And the first one that was a major hurricane after that didn't hit in the Gulf was Hurricane Diana in 1984, and then we had Gloria in 1985. So it seems that you have to have conditions in the atmosphere just right to drive these hurricanes up along the East Coast. More often than not, the conditions prevail where they're more likely to go into the Gulf of Mexico. I might point out, though, this year we haven't even come close to seeing a hurricane in the Gulf of Mexico.
Well, that leads into what I was wanting to talk about here, John. It seems to have been a very quiet season, and of course we're not over with the season just yet, but during different parts of the year we see hurricane formation in different parts. From now until the end of the hurricane season, where should we be looking for the formation of these hurricanes to be?
We should be looking farther west. Perhaps we could show the folks where the hurricane origins are in September. August 1st, we look all the way over to the Cape Verde Islands. And then as we get into September, we also see a lot in the vicinity of the Cape Verde Islands, although to be sure, some can develop in the Northwest Caribbean Sea and in the Gulf of Mexico. But once we get into October, then we don't look out as far. And even the ones that we see developing out there in the orange area, they are likely to be early in October. Later on, the whole place of origin of hurricanes in October shifts back to the Western Caribbean Sea. Now, as far as this season is concerned of being quiet and all that, we have a new storm named today, so we've already had 5 storms, and the normal number is only 9, and so we're not really that far behind. But what we haven't seen is much of anything in this part of the world. Number one, where it threatens the United States. We've only had one hurricane, that was Arlene, and that was just barely a hurricane, so we haven't really seen a strong hurricane. Perhaps what we're looking at today there east of Barbados constitutes the greatest threat we've had so far. Now, we can't be sure whether this is going to be a hurricane in the Caribbean Sea or not, but it is a good possibility, I do believe. And speaking of the Caribbean, I think we ought to point out that we have an unprecedented record here. As we go back 100 years, we have never had more than 2 consecutive years without a hurricane in the Caribbean Sea. We have not now had a hurricane in the Caribbean Sea, a full hurricane, since 1982. Hurricane Katrina in 1982 was the last full hurricane that we've had in the Caribbean Sea.
So it hasn't been a real quiet but not a real volatile season.
Well, it certainly has been quiet, okay, in that there has been no real threat to the United States. Okay. There's no doubt about that.
All right. We're going to take a break here, but we'll be coming back to our discussion a little bit later, and we'll still be accepting your phone calls at the numbers on the screen. Those numbers, 1-800-327-0945, and in Georgia, area code 404-434-9762. In our next segment, Glenn Schwartz recalls the worst natural disaster in U.S. history and how much worse it might be if it happened today. Plan on buying property on a barrier island? After our next segment, you may change your plans. Hurricanes seem to have a mind of their own, and though advanced technology helps us keep an eye on them now, as to what they'll do next, all we can do is make an educated guess. Here's the final segment of our documentary.
In 1900, forecaster I.M. Klein got on a horse and rode up and down this very beach trying to get people to evacuate. Some people listened, but not nearly enough. Needless to say, the warning system has improved since then.
Bill, do you have the latest recon on?
The National Hurricane Center in Miami is responsible for tracking and forecasting Atlantic hurricanes. They have 3 main tools for tracking the storms. Until satellites developed in the 60s, hurricanes over the open ocean were often completely missed. All of a sudden, a ship or island would get blasted by a storm. Not anymore. Pictures taken every 30 minutes not only detect hurricanes, but show how the storm is moving, help provide estimates on how strong it is, and on how much rain it might produce. As a hurricane gets closer to land, reconnaissance aircraft are sent to fly through the storm. These hurricane hunters take vital measurements of wind, pressure, temperature, and humidity at many levels inside the storm. Finally, when a hurricane is within 200 miles of the coast, radar goes to work. Installed in the 50s, radar gave the first clue that hurricanes had spiral bands. We now have continuous monitoring of the hurricane. When the Hurricane Center feels an area is threatened, a hurricane watch is issued. It's usually for a very large area, alerting the public, media, and local officials to the potential threat. When the threat becomes imminent, a hurricane warning is issued for a smaller section of the coast. Officials try to issue warnings at least 24 hours before landfall, but some come with 12 hours or less lead time. When the warning does come, it implies an urgent need for action. Advanced computer models have helped to improve forecasts and warnings slightly since the 60s, but only slow improvement is expected for the rest of the century.
Now, hurricanes move along in the atmosphere very much like blocks of wood move along in rivers of water. We have rivers of water in the atmosphere. Now, the rivers of water in the atmosphere are different than the rivers of water on the land in one major way. There's no river banks in the atmosphere, so the rivers move.
Look at some examples of actual hurricane tracks and you'll get an idea of how hard it might be to predict where a hurricane will go. Even if it's been moving on a straight path for days, it can turn abruptly without warning. Here's a hurricane moving northward. It's going to hit the Carolina coast, right? Wrong. It's out to sea. Give the all clear sign. No, wait, it's coming back. Because of forecast uncertainty, the large amount of warning time needed, and the relatively small area getting the full force of the hurricane, many more people are going to be evacuated than appears necessary after the storm.
There's a myth going around in the land today that says that with all those beautiful satellites up there, you must really be doing a great job. And see, every night they see those satellite pictures with their own eyes on the television. And we put them into motion and put them into color. And the myth says, with those kind of tools, you must be doing a great job forecasting. No, no. We do a great job observing. And that we do. There's no question about it. But the satellites do not make forecasts for us. They only tell us what is going on right now.
The weather experts do their best to outline the dangers of a hurricane and where and when it will strike. But it's up to each individual and each community to have plans of action ready in areas affected by hurricanes. And it's up to each individual and community to act on those plans when watches and warnings are issued.
Now, I'm not basically opposed to developing the islands. I am concerned about building death traps. And I fear that's what we've done. I fear that we've got so many people on the islands that our existing roadway systems will not allow them to get back to high ground in the lead time that we can realistically provide in the warnings.
Hurricanes are a part of nature. They help distribute the heat on Earth and often provide needed rain to dry areas. It is people who have moved to unstable beaches and leveled sand dunes. Our love affair with the beach has created the hurricane problem, which hasn't been solved by a few seawalls like this. Since we can't stop these powerful storms, the best that we can do is to learn to live with the threat.
If you live on the coast, give us a call. How do you feel about what's been said? Would you consider moving? We're taking your phone calls right now, and we'll be back for more questions and answers with John Hope. Our numbers, 1-800-327-0945, and in Georgia, area code 404-434-9762. Thanks for joining us here at the Weather Channel. I'm Colleen Wine. We're continuing our discussion on hurricanes as Eye of the Storm continues. And we had a phone call in just a couple of seconds ago. Wanted us to clarify something, John, about what exactly an El Nino is.
Well, the El Nino is a phenomenon that occurs in the Pacific periodically about once every 5 or 6 years, where the water temperatures, especially along the west coast of South America and Central America, are much warmer than they normally are. And that not only has a lot of effect on the weather, but it has the effect on the fishing industry. A lot of fish die off the coast of Peru, for example. And this effect, it's the southern oscillation El Nino, and it's felt all the way across the Pacific Ocean, way over in the West Pacific, say over around the Java and those areas is likely to be drier than normal at the same time that it is wet off the coast of South America. So it has to do mainly with sea surface temperatures. We have warm water where we normally have cold water in the eastern Pacific.
Okay, well, sometimes we get a little used to these things.
And this is pretty much in the equatorial zone that we're talking about, in a few degrees either side of the equator.
Yeah, okay, well, I hope that answers your question. Let's go back to the phones now for Altamont, Illinois. Your question, please.
Okay, my question is, when the National Weather Service gets information on the expected landfall of a hurricane, how long until it's communicated to the public, and how long do they have to evacuate or safeguard their homes?
Okay, how quick? We try to get them on right away here. How quick normally is it from the National Weather Service to the viewer?
Well, we almost immediately, as soon as, here at the Weather Channel, as soon as the information comes in from the National Hurricane Center, we have it on the air. Now, the National Hurricane Center, once they begin to write advisories on a hurricane, they do this every 6 hours, as long as the hurricane is far out at sea. But as soon as it becomes a threat to land, then the information comes in at much more frequent intervals. It'll be every 3 hours and sometimes every 2 hours, and then there would be intermediate times where they would give it every hour, say from the radar fixes and so on. But again, the normal warning time, what they try to do is not ever to give less than 12 hours warning time, a daylight warning time too, because it's much more difficult to evacuate at night than it is in the daytime. So they hope to give 12 hours. A lot of times they give more. A lot of hurricane warnings will go up 24 hours or maybe a little more than that in advance of the time that the hurricane is expected to make landfall.
So in other words, if you're told to evacuate.
Well, you'll be told to evacuate. If the order goes out to evacuate, then this means it's urgent. Don't wait. You can't wait. You must do it. You must begin right away.
Right. Okay, let's head back to the phones. Minot, North Dakota. Your question, please. You're on the air.
Yes, ma'am. Hey, John, I would like to know, how often do tornadoes accompany hurricanes?
How often tornadoes accompany hurricanes?
Well, they do it very often. Some hurricanes won't have many tornadoes at all, and other hurricanes will have a great many. Hurricane Beulah, I think that was in 1967 down in Texas. I think they had about 48 tornadoes associated with that hurricane. And we usually see this in the right semicircle of the hurricane as it makes landfall. So they vary from 1 or 2 to, in that case, more than 40 or 50. And some have none at all.
And as we saw earlier on the tape, they're not quite as intense.
Well, they're not normally quite as intense, and they're usually well embedded in the hurricane circulation. They're kind of difficult to pick out even on radars because they usually occur along the rain bands where the rain is very heavy anyway. But they're damaging enough. But we're worried about those, but not quite as worried maybe as we are about what goes on in the actual eye wall of the hurricane, because those winds can be as strong as any tornado.
Okay.
Almost any tornado.
Almost any tornado. Okay, well, we'll keep that in mind. The scene you are about to see was taped just before a hurricane made landfall, and it was shot by Weather Channel photographer Steve Angel. Steve shot many of the scenes that you've seen tonight. We still have time for a few more phone calls, so if you haven't gotten through yet, now's your chance. We'll be right back after station identification. Thanks for joining us here at the Weather Channel. I'm Colleen Wine alongside our hurricane expert John Hope. Heading right to the phones for our next question. Atlantic City, New Jersey, you're on the air.
Hi, yes. I was wondering, how late in the season has a hurricane traveled up the East Coast?
How late has it ever made it up the East Coast?
Well, certainly Hurricane Hazel in 1954, while it didn't exactly go up the East Coast, it came up just inland. So in October, they can come up in October. Most of them come up in September. Usually after the end of September, the likelihood of getting one up the East Coast diminishes pretty fast.
Okay. We'll head back to the phone now. Mineral City, Ohio. You're on the air. Your question, please.
We have a place on Anastasia Island, which is on the east coast of Florida, right below St. Augustine. Now, if a hurricane hit at low tide, would we still have to evacuate?
Well, again, it would depend on how intense the hurricane was. If it were a major hurricane, I would evacuate on the east coast of Florida. no matter whether it was low tide or high tide. Actually, the tidal range there at St. Augustine is not all that great as it is farther north. So if it's a major hurricane coming in from the ocean, I would certainly evacuate even if it was forecast to be there at low tide. And remember, the forecasts are not that precise either that far ahead. Don't forget that the time between high tide and low tide is only about 6 hours, and they might not forecast it quite that accurately. So I wouldn't want to stay there just because I thought it might get there at low tide.
Yeah, personally, I don't think I'd take the chance.
No.
If they told me to evacuate, I'd be out. Okay, we'll head back now to the phones for Flint, Michigan. You're on the air. Your question, please.
Hello, Colleen. My question is, how do other weather systems affect hurricane strength and direction, such as frontal systems, high and low pressure, or tropical waves?
Okay, how can the other effects of the atmosphere affect where it's going?
Well, again, the large-scale flow in the atmosphere is what determines where a hurricane does go. If you look at a map of the Atlantic Ocean in the summertime, it's kind of dominated by a large high-pressure area, which we call the Azores Bermuda High. And what happens is that hurricanes tend to go around the periphery of these large highs, where that's why in the deep tropics they move toward the west. When they get over in the West Atlantic, toward the western end of the high, they turn toward the north. And then when they get north of it, they go toward the northeast. And sometimes they'll kind of move parallel to a cold front. So everything is very interrelated in the atmosphere. There's nothing really goes on one place that doesn't affect the weather somewhere else. And what happens in the high latitudes a lot of times will determine which way a hurricane will go. If we get a deep trough of low pressure coming in over the United States, that's likely to make a hurricane that's been approaching the United States turn toward the north very rapidly and then turn toward the northeast.
Yeah, you assume a hurricane so powerful it would just take control of everything else.
Not really. The hurricane is really controlled by the large-scale atmospheric flow.
Very much so. I think we lost that phone call. But we have Los Angeles on the line. You're on the air. Your question, please.
Hi, Colleen. My name is Richard, and I was wondering what the chances of Los Angeles having a hurricane is.
I'm sorry, I can barely hear you. What the chances of what?
What the chances of Los Angeles having a hurricane are.
What the chances of Los Angeles? We briefly touched on this earlier.
We talked about that just a minute ago. The last major hurricane, or last hurricane, last storm that came up there with full hurricane strength from the tropics was way back in 1939, so it's not going to happen very often.
Not very often.
Not very often.
Okay, well, good gracious, the time has flown. We've been here for 90 minutes. We tried to get as many of your phone calls in as we could, and I hope we answered all of your questions. I had a couple I wanted to ask. I didn't get a chance to get them in, but I'd like to thank John Hope for being here tonight to answer your questions. And we'd all like to thank you for calling us and contributing so much to the program. Thank you again, and good night.